to another RouterGods video. My name is Humphrey Cheung, and in this video we're going to take topology 4, which is our 2 PCs and 2 routers, and we're going to practice setting up NAT overload, or otherwise known as PAT, or port address translation. So it's pretty easy, but we need to do a couple things before we set everything up. If you are doing this inside of GNS3, you probably want to right click on your router 1 and router 2, go to configure, go to R1, go to memory, and then just change the RAM size up to 256 megabytes. And the reason for this is your NAT table is going to take up a bit of memory, and if you leave the router memory at 128 megs, then it's probably going to bomb out on you and not work. So do that on routers 1 and 2. Fire it up. Now I already have my IP addresses set on routers 1 and 2. As you can see from the diagram, PC1 and PC2 use DHCP. So I'm going to need to set up DHCP on router 1. So we're going to pull over router 1 and we're going to do IP DHCP pool. Going to give it a name. And we're going to call it Bob. Not the most exciting name, but whatever, it doesn't really matter. Going to hit question mark just to see what we get here. Okay, we've got subnet, we've got update, we've got network. Network sounds pretty good, so we're going to do network, question mark, and we want to give out network 10, 10, 12, 0. Question mark there, and we're going to give it a mask of a /24. We could have also done /24, but it basically works the same. So network 10, 10, 12, 0. Going to hit enter right there. Let's do a question mark, see what else we can get. Let's see, we've got default router. Default router probably works. Default router. So this is going to give a gateway. And we want to give the gateway to PC1 of 12, 12, 10, 10, 12, 1. And we'll hit enter right there. Okay, default router 10, 10, 12, 1. Now we're going to go over to make another DHCP pool. So we're going to exit out of there. IP DHCP pool Bob. Oh, we'll call it Bob2. This network is going to be 10, 10, 13, 0 and a /24 mask. Network 10, 10, 13, 0 /24. And that default router is going to be 10, 10, 13, 1. Going to exit out of there. Okay, so we've made our DHCP pool. Let's fire up PC1. So we've got PC1. And looks like since I had a no shut on the fast Ethernet, it already got an IP address. Go over to PC2. We just have to twiddle our thumbs a bit. There we go. We've got our IP address right there. So that was pretty easy. Both of our PCs now have IP addresses. And let me just do a quick ping over to 140.111, which is the other side of the internet interface. Ping, oh, gotta move my PC window over. Ping 140.111. Let's see if that will ping out, and everything is a success. So that's good. So now we have connectivity from the PCs to the router. We now need to get connectivity from the router 1 to router 2 and vice versa. So the way we're going to do that, we're going to use a static route. Pretty simple. IP route 0000, another set of 4 zeros, and a next hop of 140.112. And we'll hit enter. And this is generally the same thing as you will see on your home Netgear or Linksys router. You'll just have a default route pointing out to your ISP or other provider. Okay, so we've got a default route from router 1. We're going to go to router 2, and we're just going to make a default route pointing back. So IP route all zeros, going back to 140.111. So we've got our static route pointing back. Gonna just do a quick verification on router 1. We'll ping all 2s. So this loop back right here. Let's see if that works. And we have a successful ping. So that's pretty cool. All right, so now let's do something cool. Let's go on PC1. Now, even though this lecture is about network address translation, let's see if I can ping the other side. I'll do a show IP route. Oh, we have IP routing turned off, but let's see if PC1 can ping the all 2s address. Hey, look, it works. Now, was that the result of network translation, or was it just normal routing? Well, if we go to router 1 and we do a show IP NAT translations, this will show the NAT table. Well, you can see nothing is there. Kind of strange. And yet the ping went through. Let's pull up the window for router 2. And let's start a debug. Debug IP packet detail. Debug IP packet detail. And now we're going to start the ping again from PC1. Ping 2222. And look at this. We have a ping coming from source 10.10.12.2 going towards myself at router 2. 10.10.12.2 is the actual IP address of PC1. So what's happening here is it is doing regular routing. There is no network address translation because we haven't set it up. What we have here is PC1 shoots it out the default route. The packet hits router 1. Router 1 has a default route going to router 2. It hits router 2. Router 2 goes, oh, okay, well, all 2s belongs to my loopback address. I'll send it to the loopback. The answer comes back from the loopback. Goes from router 2 to router 1 because of this default route. And from router 1 to PC1 because it's directly connected. Interesting. Okay, but it's not exactly what we want. What we want is router 2, instead of seeing source of 10.10.12.2, we want to have a source of 140.111. We actually want to hide RPCs behind this router. And to demonstrate another problem that we have, if I do the ping to all 2s from PC2, on our debug here, you could see we have a source of 10.10.13.2. So we are seeing everything coming from the inside network. Okay, that's bad. We don't want that. So now we're going to set up our NAT. And it's going to be pretty easy. We have to go to router 1. It's going to be a couple commands here. First, I want to do an access list. And what this access list will do is it's going to catch traffic coming from PC1 and PC2. It's going to match this network, the 10.10.12 network, and this network, the 10.10.13 network. So we're going to make a single access list with 2 lines. So we're going to do access list 1 permit 10.10.12.0 and make it a /24 wildcard mask. Then we're going to make another access list permit 10.10.13.0.0.0.255. Okay, so these 2 access lists are going to match traffic coming from these 2 links. And we'll be hooking these access lists to a NAT command in a couple minutes. Okay, now we have to go into the interfaces and set the inside of our NAT translation and the outside. So inside is before translation and outside is going to be after translation. So these 2 interfaces are going to be NAT inside, and this interface fast10 is going to be NAT outside. So we're going to go int fast00 IP NAT inside. You can see it sticks a little bit as NAT is enabled. Then we're going to go int fast01 IP NAT inside. You can have multiple interfaces as inside, doesn't really matter. Then we're going to go to our outside interface, which is interface fast10 IP NAT outside. Okay, so we have configured our interfaces for inside and outside. Now we're going to configure the NAT pool. The NAT pool is going to determine how many real IP addresses we will use. In this case, we only have one real address, and so we're going to overload all the inside IPs, the two inside IPs, over this single IP. So we're going to do this command, IP NAT pool, and we have to give it a name. So when I do the question mark there, it's just asking for pool name. Now the Cisco documentation, they go overload in abbreviation, so OVRLD. You could call it David, you could call it thumbs up, doesn't really matter. You could call it my NAT pool. Yeah, that sounds pretty good. My NAT pool right there. You have to put in your outside IP address, your real IP address is 140.111. Let's hit question mark after that. Ending IP address, well, it's the same thing, 140.111. Do another question mark, net mask. And then 255.255.255.0. Now this is a little bit of confusion for some people because they're looking at this going, well, this is a single IP address. Why would I use a net mask of a /24? Well, you're using the net mask of /24 because this is not saying how many IP addresses are here. This net mask is the net mask given to you by your internet service provider. So if your internet service provider says use a /24, it's going to be a /24. Now on a regular small office, home office type of router like a Netgear or a D-Link, the router figures all of this automatically because your hosting provider, your ISP, is sending this information down via DHCP. Just going to hit enter right there. That's our NAT pool. Then we're going to have a second command, IP NAT inside source list 1. So what this says is I'm going to take all the inside addresses. I'm going to look for them using the access list. Okay, so take all the inside IP addresses, look for those using access list 1, and then we're going to translate it into this pool, and we called our pool my NAT pool. So we're translating it all into one IP address, and we have to add in the word overload, and we'll hit enter right there. Okay, let's see if this works. We're going to go back to PC1. PC1 right there. Gonna hit the up arrow, do our ping. Gonna move router 1 out of the way, go back to router 2. Our debug is still going on router 2. Start our ping. Ping is successful. And as we look over to router 2's debug, you will see it comes from the source of 140.111. Success. Now we go over to PC2. Let's start the same ping. And look at that, a source of 140.111. It looks like it came from the same place, the same outside IP, and life is great. So that was a quick and easy video about NAT overload or port address translation. Thanks for watching.